Welcome to Learn Yourself. Today we are going to understand about free fall and acceleration due to gravity and the constant G. These all topics are under CBSE Std-9 syllabus from 10th chapter Gravitation. So let us understand first what is a free fall. When I am dropping something from my hand, that is a free fall. If I am putting little bit force on that, then that is not a free fall. Free falling means apple is falling from the tree. That is a free fall. When any external force is not applicable on the object and it is falling and it is going towards the earth because of the earth's gravitational pull or force, that is termed as a free fall. When you are heating something, when you are throwing something, that is not considered as free fall if it is falling by its own and it is getting acceleration and it is getting a motion because of the earth gravitational force and it is hitting the ground, then it is a free fall because there is no external force applicable on that in that situation. Now let us understand the theory. Earth attracts object towards it and this is due to the gravitational force. When object falls under this force alone, when only and only gravitational pull or gravitational force is there, is applicable on the object, then we termed this fall as a free fall. And what is the condition? There should be no other external force or no other any kind of force should acting on that. No change in direction of the motion. While this fall is happening, there will be no change in the direction because it will come straight towards the down. So there is no change in direction of the motion, but there is a change in magnitude in velocity. Magnitude in velocity, that means velocity will change. When it is falling, its velocity will change. And what is the change in velocity? That is acceleration. That is acceleration. So when the object is falling due to the gravity, it will gain acceleration. It will gain acceleration. Acceleration, and that acceleration which has been attained by an object due to the gravitational force of the earth, that is known as acceleration due to gravity. Because there is no external force, only due to earth gravitational force it is getting pulled and it is accelerated. So that's why it is termed as acceleration due to gravity. Now the constant G we are using for this acceleration due to gravity term, and the unit for G is meter per second square, same as acceleration, same as acceleration unit. Now let us find out formulas to calculate the G or how to find out the G for any particular object, and we will learn how to calculate the value for constant G. Now let us find out formula for acceleration due to gravity. We know that F equals to ma, but in this formula A is acceleration and here our G is also acceleration due to gravity. So instead of A, we are writing here F equals to m into G. We have replaced A with the G because this is also acceleration, but this acceleration is due to gravity. But this is in term, this is acceleration, so we have replaced A with the G. Now, in earlier formulas we have seen what is force equals to. Force equals to, we know that F equals to G, capital M into small m divided by d square. This is according to the universal gravitational law. So F equals to G, the product of both of the object's masses, and in denominator the distance square. So F equals to, this is a formula. So here this we are going to replace in this equation. This is first equation. In this first equation we are going to put this value for F. So it is going to be G into m into small m divided by d square equals to m into G. M into G. Now at both the side m is there. So we are going to cancel out this small m because both the sides small m are there. So we are going to cancel this out. So here we are going to get the value for small g, that is acceleration due to gravity, is equal to g m divided by d square. This is a formula to find out the acceleration due to gravity. Now, when we are calculating this acceleration due to gravity, the earth will come in a picture, because always the gravitational pull will be from the earth. So, any object which is lying on the earth or which is lying near the surface of the earth is always getting attracted towards the earth. So, when we are calculating the distance for the object and to the earth, because here whatever distance we have taken from the formula f, that was something like this, that from the center of the first object till the center of the second object, this distance we have calculated as d. Now here we are calculating this formula with earth's and the object's distance. So any object which is lying on the earth or which is lying near to the surface of the earth will come in its gravitational force area. So how to calculate that? So for that we are taking a radius of the earth, because whatever object is lying near the surface of the area, that distance and which is lying on the surface of the earth, is the difference between that two is very negligible. So we are always counting that as radius of the earth. Now what is the radius of the earth? For example, this is earth, and this from the center till the circumference, this is going to be the radius of the earth. So any object which is lying on the earth or which is lying near to earth, it is almost similar as the radius of the earth, because the distance of the radius of the earth is very high and this much difference is very negligible. So in this formula, whenever we are taking a distance of the two objects, that from the center of the earth till the object which is lying on or near the earth's surface, that will be equals to the radius of the earth. So here we are going to replace this d with the r. So our new formula is going to be g equals to capital G m divided by r square. This r is a radius of the earth. Now this is our new formula which we are going to use it for the numerical. So this formula we need to remember. Now let us calculate the value of the g, and we'll find out that what is the value for acceleration due to gravity of the earth. Here we are going to find out the value for the g. So our equation is capital G into mass of the earth divided by radius of the earth square. So here g, we know that it is 6.7 into 11 Newton meter square per kg square. M is mass of the earth. This is mass of the earth. This is radius of the earth. G is universal gravitational constant and its value is this. So now let us put all this value in this equation. So we are going to get here 6.7 10 raised to 11 Newton meter square per kg square into mass of the earth. So it is 6 into 10 raised to 24 kg. In the denominator, the radius of the earth, that is 6.4 into 10 raised to 6 meter. Now when we are going to solve this, we will get here 9.8 meter per second square. So this is the value for the g. This is the value for the g, and this we are going to use in each and every numerical. Now the value of this g is different at different places on the earth. Why? Because our earth is not a perfect sphere. So at the poles the mass is concentrated here, and at north pole and south pole the mass is concentrated. At these places the g's value is higher compared to at the equator. So as we are going from the equator to the poles, the g's value is continuously increasing, whereas from the poles, when we are coming towards the equator, the g's value is decreasing. So This changes will be there because the earth is not a perfect sphere, and here at the north pole and south pole, G's value is more compared to the G's value at the equator. So hope this video has solved your doubt. In coming videos we are going to cover some important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.